Bismillahirrahmanirrahim. Hello students and good afternoon. How are you today? Are you all okay? I don't know if this is good news or not, but I have heard that the university seems to want to hold classes in person. Classes may be in person for a few more weeks as conditions improve. So in that case, I think we can say goodbye to online classes. What's your preference? Do you like online classes or in-person classes? What do you prefer? Uh, no, no. I want you to summarize the first chapter only in one page, no more, no more. Okay, so you should try. It's a kind of art. It's a kind of art. Summarizing is art, really. So you must be able to find the important contents of the first chapter and summarize it in one page. Okay, it should be typed in English or Persian, and I want the PDF file of this page. Okay, so could you understand what I said at the first of class? I said that I have heard that the university wants to hold classes in person in future weeks, in the near future. Classes in person, not online classes. Classes may be in person for few more weeks when conditions improve. So, what do you think about it? Do you agree? Do you like in-person class or online class? I like online classes too. But if university decides we have no way, there is not any other way to attend in-person classes. And I suppose you should travel to Mashhad if you are in Iraq now. All of you in Iraq, I think, yeah? Wow, so it's difficult. Maybe, yeah, okay. Maybe this rule is applied for Iranian students only for this semester, but the future semester, the next semester, I don't know. So we hope we can continue our classes online. What I really want and I'm interested in visiting you in classes. It's really good. Teachers like to see uh, their students and talk to them face to face. In online mode, I can just look at the monitor of my laptop and talk to the wall, to the monitor, and it's not a good sense. Thank you. Okay, so let's continue our lesson. I must stop sharing and I must change the PDF file because again I made some changes to the PDF file. I added some new slides and I am going to upload the new PDF file now. Okay. If you remember, we were talking about system architecture and software architectures in distributed systems. We begin our discussion with software architectures and we continue it with system architectures. I'm waiting for uploading the file. It's going to be finished. Wow, it took too long. Okay, done. So, we talked about three-layered view. If you remember, we talked about three-layered view and I gave you an example. For example, searching on Google is a good example of three-layered view of the applications in distributed systems. So, and continue, uh, the three-layer separation discussed offers various methods for the physical distribution of client-server applications in several machines. You know, we are talking about physical distribution of client-server applications, and that is system architecture. The simplest organization has only two types of machines. I repeat it again. The simplest organization has only two types of machines. Which are those machines? Two types of machines. Which are them? Exactly. Client and server. Client and server. So we have only two types of machines. It's the simplest organization. In this organization, everything is managed by a server because server is responsible to provide services. While the client is just a terminal that probably has a nice user interface, you know. Clients has user interface. The picture you can see is the only difference between two machines, the server and the client. This is called two-tiered architecture. Two-tiered architectures. Two-tiered means two separation, two part architecture. We have two parts, okay? An organization may be only part of the user interface on the client. Only part of the user interface on the client. In this case, the display can be controlled by the server because the server has a part of user interface too. In other words, the server can control the user interface on the client. This organization is actually figure A. Figure A, the first picture, the left picture. The first picture from left, figure A. As you can see, on client, what we have is a part of user interface. So what do we have on server? A part of user interface, application layer, and database layer. Okay. It is an organization. We can organize to physically place components on real machines. We have two types of machines, client and server. And in the first organization, we place a part of user interface on client machine and the other parts on server machine. So it is an architecture. It is an architecture with two types of machines. System architecture. Why do I say it is a system architecture? What was the definition of system architecture? What's the definition of system, or what is it, system architecture in distributed systems? Yes, place components on real machines. How we can place components on real machines? System architecture talks about it. And in this organization, you can see that we organize components on real machines. We decide to place a part of user interface on client machine and also part of user interface and application layer and database layer on server. So it is a system architecture. Alternatively, the entire user interface can be placed on the client. See figure B. See figure B. The total user interface can be placed on the client. As you can see, it is. This section is called front end. Front end. If you are a programmer, if you are a web programmer, you may be familiar with this concept, front end and back end. Have you heard it, front end and back end? No? Okay, no problem. Consider an HTML, an HTML web page, okay? In front end, we can design user interface. For example, tables, buttons, I don't know, radio buttons, menus, okay? It is called front end. And back end is some software that is executed on server. The software, for example, adding, inserting a new record on database, deleting a record on database, or updating a record in database. It is done by an application on server side. It is called backend. So if we use front end completely in the client side, and also we place application layer and database layer on server side, we can organize another style. Clear? Many websites use this architecture style. It means all the front end and all the user interface is placed on client side, and application processing and also database are placed on server side. Continuing this argument, we may transfer some parts of the application to the client. We may transfer some parts of the application to the client. Look at figure C. Look at figure C. As you can see, we have transferred some parts of the application layer to the client. Oh, okay. In other words, front end will include a part of the application, and some processing will be done in it. We have some processing functions on client here. Could you name an example? Server-side rule checking? No, client-side rule checking. In fact, we can have client-side rule checking. If we want to transfer some processing, some applications on client side, we can name an example of filling out a form and checking the correct input structure on the client. For example, you want to register in a website, and you have to fill out a form, registration form. Okay, so we have different fields: name, family, birth date, and for example, national number, email, address, and so on. Okay, when you fill out this form and just you want to press the submit button, before the form is submitted to the server, we have some JavaScript codes that checks the correct format of your input. For example, it checks if you have entered your email address in correct format or not. Or it can check if you have entered your age in a correct format or not. If you enter some characters instead of your age, you know the age must be a number. But if you input some characters instead of number for your age, you will see a notification, okay? And it tells you that you must enter your age in correct form before sending the form to the server. It is processed on client on your computer. Okay, so it is another organization. I suppose you can guess what is the next organization. The organization shown in D and E, figures D and E, are related to when the processing and application section is entirely in the client. the processing and application section is entirely, totally in the client. In this case, the client is a complete processor machine that communicates with the database. Can you give me an example of such designs, such architectures? I'm talking about figures C and D and E. When we have the application section on client. For example, suppose that you have a software to work with a database. For example, Microsoft Database Console. Okay, it's a software to connect to a database and work with it. And the database is stored on a server. The server is connected to a network, and so you can connect to a server. All the application is installed on your machine, on your computer, and you can connect to the database directly. And so you can retrieve, read, insert, delete, or update records. Got it? Yes, SQL Server. If you work with SQL Server, you can understand it completely. The name of the software is exactly SQL Server Management Console. SQL Server Management Console. It's a console, it's an application to connect to databases and to manipulate data. So consider software that connects to a database on a server. Searching and modifying the database is done on the client, but the data is stored on the server. This is related to the figure D. Finally, in figure E, part of the data is also transferred to the client. If you look at this picture, figure E, you can see that part of the data is also transferred to the client. That is, the storage disk on the client stores part of the data. I expect you give me a good example of such design. I have talked about in previous sessions. Search engine? No, it's not about search engine. In search engine, the application is on server side. You cannot have Google algorithms on your client machine, on your own machine, okay? MySQL, no. We have talked about it a lot. Look at figure E. As you can see, part of a data is also transferred to the client, okay? What about web caching? Web caching. Can you remember what is it? Web caching? Cache, web caching. Thank you, Mrs. Rashaw. Yes, exactly. Yes, yes, exactly. In web caching, you have some data on your own machine. Okay, so as you can see, some parts of data is transferred to the client side. It is another design. Yes, we have a problem. It's not problem, it's an issue with web caching, and it is about synchronization with with the master. Okay, so we must apply some policies to be updated and uh, to have a good and acceptable performance. It's a trade-off between synchronization and performance, transparency and performance. We have talked about it a lot in previous sessions. So, which one do you like? Which one is better? Look at this picture, A to D, A, B, C, D, E. Which design is more preferable? Which one do you prefer? C, why? Store your information. E. Do you like to do all things on clients like E, or all things on server like A, or some things on server and something on client like C, B, and D? Which one is good? There is no a correct answer for this question. Indeed, we have not been able to definitely say that which one is good or which one is better. But there is a rule. There is a rule here, okay? What's the rule? From a system administrator's point of view, from the point of view of system administrator, fat clients. Fat clients? What is fat clients? When I say fat client, fat means farbe, fat, F-A-T, fat clients. Which one we can have fat client? Which client is fat in this picture? Yes, fat, exactly, fat. Which client is fat in this picture? A, the client is fat here, or the client is thin? A and B clients are thin, T-H-I-N, thin. A and B clients in A and B are thin, but in D and E clients are fat. means clients do a lot of work. When I say fat clients, I mean those who do a lot of work. And when I say thin clients, I mean those who do less of work. Okay, so from a point of view of system administrator, fat clients are not optimal. Fat clients are not optimal. There are also some security issues with them. On the other hand, thin clients are simpler. See A and B. Thin clients are simpler, but they are less efficient. Why they are less efficient? Because all things should be done on server side. So the efficiency may be decreased. Very good. I'm glad that you say clear. Really good. Yes, the client in E is fat and the client in A and B are thin. Yes. Fat clients are those clients who do a lot of work, like E and D. Thin clients are those who do less work, like A and B. That's it. And I said that system administrators believe that fat clients are not optimal. On the other hand, thin clients are simpler, but they are less efficient. Why they are less efficient is that all things must be done on server side. So the efficiency is decreased. Good. We talked about two-tiered client-server configuration. Also, we talked about three-tiered, each layer on separate machine. We have user interface, application, and database layer. It is called three-tiered layer. Here you can see a three-tiered layer. In this design, servers may act as clients. Look at this picture. We have client and user interface, presentation layer, application server, and database server. When we separate data and application in different servers, we can have this style. Firstly, user request to get or to use a service, and application server process it. It needs some data, so application server request data from database server return data to the application server, and application server return result to the client. So in this example, application server is server and is client. Can you say why application server is server and client? Yes, need to act as a client. Follow again. See here. Here, client request operation. Okay, application server receive the request. So here, application server acts as client, as server, and it processes the request. Now, application server needs data, so it requests data here from database server. Now, application server acts as client because he needs some services from other machines. Database server receives the request from application server and provides the data and return data to the application server. Here, application server provides services for client. So now, application server acts as server and return the result to the client. Got it? Very good. So, decentralized architectures. We want to say about decentralized architectures. All we talked about was about centralized architectures. Client server is a centralized architecture. Okay, let me go back to which slide? Here. We said that system architectures place components on real machines physically. There are three system architectures: centralized, decentralized, and hybrid of those two. Okay, we talked about centralized architecture. Client server is an example of centralized architecture. And now, decentralized architecture. We want to know what is decentralized architecture in system architectures. Please pay attention. It seems a bit complex, more complex than the previous design. Okay, so it needs more attention. In traditional client-server architectures, we had vertical distribution. Vertical distribution. It means each level serves a different purpose in the system. Each level serves a different purpose in the system. In other words, I can say we had logically different components on different nodes. Okay, it is vertical distribution. In this distribution, vertical distribution, we place different components logically in different machines. Okay, so that is why we say it's vertical fragmentation or vertical distribution. Assume a table in a database. Okay, a table of a database. The table contains many columns or attributes, and we can divide a table by its columns. For example, the first three columns can be stored in a server, and the other columns can be stored on different server. Columns, vertical columns. So that is why we say this architecture is vertical. It's like vertical distribution in databases. But in horizontal distribution, horizontal means افق, horizontal distribution. It is called peer-to-peer, peer-to-peer distribution, peer-to-peer model. In this model, each node has roughly the same processing capabilities and stores and manages part of the total system data. I repeat it again. Each node has roughly the same processing capabilities, between all the nodes. It's different from client server. Processing capabilities were on server, okay, on client server model. But here in peer-to-peer, each node has the same processing capabilities and stores and manages part of the total system data. So the data is decentralized here. We do not have a server to store data here. The data is distributed between clients, between nodes. There is no client here. Between nodes, between machines. We do not have a machine called server. We do not have a machine called client. All the nodes are the same. They can calculate, they can store data, they can manage. It is peer-to-peer model. Is it clear for you? Yes, Miss Marwe. Yes, it's okay. Yeah, very good. So that is why we say decentralized architecture. Why it is decentralized? Because the data is decentralized here. What is the advantage of horizontal distribution or peer-to-peer? Better load balancing. We have load balancing here. Load balancing means توازن. Load balancing means توازن. موازنه. Okay? Load balancing. In client model, the servers are very heavy. Why? Because all the computations and calculations and processes are done on server. And also the databases are heavy, database servers. But the clients may be thin. Okay, so we do not have load balancing. But in this model, because each node has the same processing capabilities, we would have load balancing here. But unfortunately, it is more difficult and harder to manage compared to client server. It's more difficult, it's harder to manage compared to client server. The managing is more difficult. In peer-to-peer architecture model, nodes act as both client and server. All nodes in peer-to-peer style act as both client and server. Interaction is symmetric. So we will have a symmetric interaction between nodes here. Each node acts as a server for part of the total system data. And we will have overlay network here. Overlay network here. What does it mean, overlay network? Overlay network. Overlay networks are logical or virtual networks. Okay? Virtual networks, logical networks, built on top of a physical network. So we have a physical network. It's okay. Okay. We all know that we must have a physical network. But overlay network is a logical and virtual network built on top of this physical network. A link between two nodes in the overlay may consist of several physical links. Again, one link between two nodes in the overlay may consist of several physical links because it's logical. Messages in the overlay are sent to logical addresses, not physical addresses. We have some physical addresses like IP address. IP address is a physical address, exact address of a machine. But messages in the overlay network are sent to logical addresses. And we have many different approaches to resolve logical addresses to physical, to convert logical addresses to physical. There are many different approaches. That is overlay networks. Yes, exactly. That is a network which the nodes are formed by the processes and the links represent. Yes. So overlay network connect nodes in the peer-to-peer system. Nodes in the overlay use their own addressing system for storing and retrieving data in the system. And also nodes can route requests to locations that may not be known by the requester. It is logical address. Okay, I talked about overlay networks, and so let me show you an example of overlay network here. As you can see, circles represent nodes in the network. It's overlay network, okay? Blue nodes are also part of the overlay network. Dotted lines represent virtual links. Dotted lines are not physical links. Solid lines are physical links, but dotted lines are logical and virtual links. And actual routing is based on TCP/IP protocols. TCP/IP protocols to resolve logical addresses to physical IP addresses. And we can have structured peer-to-peer and unstructured peer-to-peer and also a hybrid peer-to-peer. In structured peer-to-peer, nodes are organized following a specific distributed data structure. So the distributed data has structure in this model. But unstructured peer-to-peer nodes have randomly selected neighbors in this network. Let me talk about structured peer-to-peer architectures. Each node in a peer-to-peer system knows how to contact several other nodes. Again, each node in a P2P system knows how to connect several other nodes. And as I said, the overlay network may be structured or unstructured. Structured means nodes and content are connected according to some design that simplifies later lookups. Unstructured means content is assigned to nodes without regard to the network topology. We do not have anything, we do not know anything about network topology here. Structured peer-to-peer, a common approach is to use a distributed hash table here. It is called DHT, distributed hash table, yes. A common approach to use a distributed hash table to organize the nodes. We want to organize the nodes in the overlay network. So we can use DHT, distributed hash table. Do you know what is hash table? No? Yes? Okay. Hashing is a technique to produce and to assign some values to some keys. We have key and value, okay? For every key, we generate a value. For every key, we generate a value. And we do not have the same key in our data. So we must not have the same and equal values. How we can generate values for keys? It is done by hashing algorithms. So, traditional hash functions, some functions that doing hashing, okay, generate values for every key. We pass a key to the function and it returns a value for that key, a unique value for that key. So traditional hash functions convert a key to a hash value, which can be used as an index into a hash table. So it can be an index, unique index for every key. Keys are unique and each represents an object to store in the table. Very good. So the hash function value is used to insert an object in the hash table and to retrieve it. We have a table. In this table we store keys, different keys, and when we must to retrieve a key, we must have index for every key. And how we can generate these indexes for keys? We use hash functions to generate indexes, these values. That's it. So in a DHT, data objects and nodes are each assigned a key. It's important, I repeat it again. In a DHT, distributed hash table, DHT. In a DHT, data objects and nodes in the network are each assigned a key which hashes to a random number from a very large identifier space. Why a large identifier space do we need? To ensure that they are unique. Because we select values randomly and we want to decrease the probability that we select 2 times a random number. Okay, so we can use a very large space to generate random numbers. For example, if our space contains numbers 1 to 10, okay, 1 to 10, we have 10 numbers here. If we randomly select a number 2 times, the probability that these two numbers are the same is high because we have only 10 numbers. But if we have 1 million numbers and if we select randomly a number 2 times, the probability that these two numbers are the same is very, very low, near zero. That is why we use a very large space. And a mapping function assigns objects to nodes based on the hash function value that is generated. We can say about characteristics of DHT here. Characteristics of DHT. It's scalable to thousands, even millions of network nodes. So DHT is scalable to millions of network nodes. It works for millions of network nodes, so it's scalable. Search time increases more slowly than the size. It means we can have a time complexity of O log n, O logarithm n. It's very good time order. It is fault tolerant also. Fault tolerant. It is able to reorganize itself when nodes fail. If some nodes fail, so the DHT is able to reorganize itself. It is also decentralized. No central coordinator is here. So decentralized algorithms are needed too. That's it. Clear? Very good, very good. Thank you. I know this chapter is a bit more difficult than the previous chapter because in the previous chapter we talked about basics and fundamental informations. Okay, so it was about general information about distributed systems. It was easy, but this chapter needs more attention. Now I can give you two options. Here I can give you two options. Option one, stop here and finish teaching and continue next session. Option two, I can continue to teach. So which one do you want? Which one do you prefer? Okay, no problem. What's your question, Miss Nia? Do you want to talk? If yes, I can enable your microphone. So please raise your hand. It's difficult to find you. Okay. Hello, if you hear me, you can speak.
Yes, I hear you, Doctor. Salam, Doctor. Doctor, I have some question about supercomputer. The
Supercomputers,
system,
the previous chapter, yes.
yes, Doctor. The system used is parallel system. But you asked this question if it is parallel or distributed system. I lost here. Is a parallel system, but cabinet or the CPU inside is using the system distributed system? That question I asked the doctor. Sorry.
Okay. I said that there is argument between some people and some people that have idea on parallel computing and distributed computing. And I also said that to me it's very difficult to distinguish between parallel computing and distributed computing. They are similar in some conditions and some situations, and they have some differences. I talked about similarities and difference, but I add this note that uh, to me, in my point of view, parallel computing is a type of distributed system because it satisfies the properties and the conditions of distributed system definition. In distributed system definition, if you remember, we said that distributed system is a collection of independent machines, and users can see these machines as a single coherent system. We can see this definition in parallel computing too. So it satisfies these two conditions. And I believe that parallel computing is a type of distributed system. Clear?
Yeah, that means the supercomputer it's together by a parallel system, but the system used is a distributed system. Like this, that's doctor?
Yeah.
Very much, doctor, for explanation.
Thank you. You're welcome. Okay, so most of the students want to finish teaching here. I respect your idea, I respect your request, and I hope you will have a good evening, and I can say goodbye now. خدا حافظ.